Right. Well, good afternoon, everyone. Thank you for being with us today. The best panel is always right after lunch, so you are in for a treat. My name is Ernest Scheider. I'm with Reuters, and I'm joined today by a top-notch panel, two of whom are here in person, and one is joining us at 3 a.m. from China, so we're very grateful for his participation. To my left, we have Christina Kallmann-Schuler from DMM Advisory Group, Francisco Acuna, joined today from CRU, and from China, Richard Zhu with ICA. Our topic today is extremely timely. We're discussing substitution, which was a huge topic this morning at the panel, and so excited to dig into this with you all today. As part of our presentation, ICA is releasing some slides today and some data on substitution demand, and it's about 4 or 5 slides in there, but one key data point that sticks out is from ICA's perspective, the total risk of substitution from EVs, renewable, and civil and building construction could reach 1.7% of total use by 2035. And 1.7% might not sound like a large number, but when you reflect on the Las Bambas situation from last year and sort of the upheaval around production being blocked, that was 2% of global supply. So that 1.7% puts that a little bit in context here. Given that EVs are such a huge part of this question, I would love to start with Christina, and if you could talk about how should we be thinking about specifically substitution risk in the EV space, especially as we're going to have this supply-demand mismatch, going out into the next decades.
Absolutely. Thank you for your question. Ernest, you can hear me. EVs is an interesting topic. Also, Vanessa mentioned this in the morning. As you can imagine in an EVs, that the two main applications of copper is the electric motor and the automotive wire harness, which is connecting the battery with all the applications within the car which use electricity. Now, electric motors will need to provide performance. There is a substitution risk is very low. In terms of the automotive wire harness, the only area where we can see risk of substitution is the high voltage cable, battery cable, which connects the battery with the electric motor, which is actually the largest diameter of cable. As you can see, EV is an application which is still developing. It's not a mature product. So automotive manufacturers and OEMs experimenting with new materials, with new technologies to find the best solution. And the best solution is always range. This is the key issue at the moment with EV. The range is not enough. So how is the materials impact the range? For example, if they use aluminum for the high voltage cable, it's a lower weight. So it has a positive impact on the range, but there is also electrical loss through the lower conductivity of copper. So this reduces the range. So it's always experimenting. And for example, Tesla tried to use using aluminum as an experiment in the 3 series in China to see how it works. We heard also some German manufacturers are playing with the idea, but it seems to be this is not matured enough to enter the mass market.
And can you maybe unpack a little bit more? What about for like EV charging stations, things that don't have to move? Is there more substitution going on there, you think, or could?
It's always depends on what is part. If it's a part of the distribution network, then they will use the traditional material of the distribution network, which is very often it's a combination of copper and aluminum, but it's moving towards aluminum. But again, if it's a high-performance charging station, it has to be copper because the conductivity is copper is required.
Gotcha. And I just want to point out to our audience, we've got the slide behind us here on the screen, and we'll be bouncing around them today during our presentation. But ICA will be releasing these later today, so they will have those available for you. I'd just love to turn to Francisco now, and if we could talk sort of more broadly on supply and demand in the context of this EV transition. How, Francisco, do you, from your perspective, see low supply affecting the broader green energy transition beyond EV thematic?
Well, thanks for the question, and I think, I would like to take a step back and understanding, I think it was the previous slide, if someone can Yeah, exactly. Just to give some perspective, I think, and when we look at this forecast, basically this collaboration we did with ICA, so you can see here in the table, we estimate around 7.9, let's say 8 million tons in terms of growth of copper consumption. What's interesting, and I think what makes things different to what it was maybe 10 years ago, maybe not so long ago, is that at least 65% of that growth will come from quote-unquote new applications. That will be renewables, that will be EVs, that will be incremental grid as well associated to that green transition. So even though building construction will continue to be the major copper-consuming sector, what's interesting now is that maybe there is an additional degree of uncertainties, and as we were just discussing now, because this 65% will come from these new applications. In that context, as you can see in the table, the largest growth will come from electric vehicles. And I think that sort of poses some, obviously risks and opportunities. We were talking about the likelihood of the risk of future substitution. So just to give some context as well, and stepping, again, a step back, when we talk about risk of substitution, what we're looking here is what is our base case forecast, and then what is the potential additional substitution that we could see. Okay, so we're not taking into account potential changes in demand overall, as let's say higher growth of penetrations of EVs or lower penetration of EVs. This is particularly associated to substitution. So I think it's interesting to see how obviously the focus is on electric vehicles and renewables because of this, but still remember that the largest share of, the largest market for demand of copper consumption is still the civil and construction sector. Okay, so in that context, particularly in countries like, and maybe we'll discuss a bit more on this later, countries like in China, in India, big consumers, there's still regulation that supports the use of copper over aluminum, okay? So I think when we are sort of comparing all of these different applications and sectors, and we see these growth trajectories, we can't see everything with the same scope. And as was pointed out this morning as well, I think there's still a lot of developments on EVs. Christina was just talking about range. Obviously, cost is a big influence. So I think there's still a lot of developments. There are other critical metals also associated to batteries, like lithium. We saw it with the recent spike in lithium prices, how companies are reacting to have batteries with less amount of lithium. Obviously, cobalt has been in a discussion as well. Maybe copper, not so much till today. I think there is a little bit of concern about future supply. And we were hearing this morning as well how difficult it is to bring new mine projects to production, to actually in execution. So I think we are facing here a couple things in terms of these new applications, new technology developments, some concerns about potential future supply, and then some cost impacts, effects, prices as well. That will always be an issue. So I think we're going to get a bit more in this conversation as we continue in this session. But I think it's always important to keep, that broad picture, to look at that picture in order to have an idea what will this really translate into numbers. So you were making the comparison with Las Bambas. Again, 7.9 maybe doesn't sound, what does the number really means? That's, pretty much Chile and Peru's combined production of primary copper. So, it's a big number. Yeah.
On that point, Francisco, you mentioned sort of new mines, and sort of certainly that thematic came up a lot this morning. Wanted to turn to Richard in China, and if we could, Richard, get your thoughts on the recycling piece of this. Could we see more recycling take over and in the quote-unquote substitutions, rather than an aluminum take place, are we being substituted with recycled copper, and sort of how we should be thinking through that? Richard, welcome your thoughts.
Yeah, sorry I couldn't be there, but just real quick on the issue of secondary material, if you will. I do think that there will be tremendous increase in secondary availability. Whether or not those available secondary materials will be recycled or collected and processed, it's a different question. We are studying that. Now on the impact of secondary materials on substitution, I think it's not a direct link because secondary materials is really related to the supply end. You know, what becomes available as raw material for new products. So it's really a supply end issue. But copper is one of those materials that, you know, the more you use, the more you will have. So from that perspective, you know, today's usage will become future's supply, and we're trying to you know, put that picture together so that manufacturers, consumers, and even policymakers will not make immature or incorrect decisions due to concern of future supply, if you will.
Gotcha. Thank you, Richard. I should say that we will have a time for question and answer towards the end of our hour, so please be thinking of questions you might have for our panel. One question that I do want to look after is geography, and it's from slide 6 here. Excuse me. Slide 5, excuse me. I'm going to throw this open to all three panelists here. We've got the greatest substitution risk could take place in China and North America. And China perhaps makes sense, given a lot of the EV manufacturing that goes on there, but North America as well. So I'd sort of throw it open to all three panelists, sort of thoughts as to geographically why we might see this breakdown by region. Maybe Christine, I'll start with you.
Yeah, it's two interesting geographic regions which are completely opposite. With China, and I think Richard will comment on this, is traditionally a geographic region which is loyal to copper. And the reason for this is a mixture of habits, political reasons, and the risk is there that this support for copper will disappear in the future. Of course, China is half of the copper market in terms of demand, and if the substitution is taking off there, this will have an impact on the substitution figures globally. The US is another area which is a very price-sensitive market. So if substitution is happening, is US very often on the forefront of substitution, forefront of trying to find new technologies to reduce cost with substitution. An interesting choice bringing in Europe in this triangle. Europe is the source of a lot of regulations, and a lot of regulations like energy efficiency, which is favoring copper. So we expect Europe having a leading role in energy efficiency and similar regulation, and also environmental protection, which will probably spread all over the world and will have a positive effect on the use of copper.
Gotcha. And Francisco, maybe welcome your thoughts on this, and how important, you know, Christina certainly mentioned regulation, as did you, but what about other countries that might not necessarily require the use of copper? Is that, is copper's physical properties still enough to maintain the demand there, you think?
Yeah, well, I think maybe the U.S. could be an example of that. That while you know, there were some incidents, particularly in the, you know, building and construction side, like early in the 70s, when it was sort of trying to be introduced. Even though there's no actual regulation on it, as opposed to, let's say, China in this case, still, you know, there is a broad understanding of the benefits in terms of safety of the use of copper for those types of applications. So I think in terms of when we talk about in terms of region, where is the highest risk? Also, maybe what we really mean by that, in the sense that obviously that is associated to a metric. So, being China the largest copper consumer, so any change in some of those sectors will reflect in a large amount of potential substitution, right? So in that context, still China being in the front of development of EVs or sales of EVs, at least in the forecast period that we looked at, which is up to 2035, China will continue to be, like I said before, number one in terms of units sold, right? So any changes in technology that could affect, particularly in China, will have a larger impact, and therefore we will associate a larger risk. Okay, then there are some other, you know, type of applications where we see that, you know, substitutions have sort of reached maybe a peak. I mean, there are like things like piping and things like that, right, where the substitution was a bit more obvious, just in terms of price. So every time you have, you know, the typical rule of thumb is 3 to 1 copper price to aluminum price. those type of things. It doesn't really apply to every application. So in some contexts, it will be associated to safety and regulation. In others will be, particularly with new technologies, it's not that easy for, let's say, a battery manufacturer or automobile manufacturer to switch the whole production line, to go from, let's say, copper to aluminum. So in that context, I think it's yet to be seen how fast those transition happens. And I think, again, I want to point it out that the risk, when we talk about risk, is very relevant, the size. So therefore, China still will be, a major force in terms of copper consumption, and also in these particular applications. As well, in terms of renewables, obviously will affect as well what type of renewable you're using. So to give an example, wind power, for instance, can be very different between onshore and offshore wind generation. So it could be a bit more double the amount of intensity of copper use in offshore wind because of all the power cables, just basically to get the power from the actual turbine to a substation. In countries where that is more predominant, we see, let's say, lesser risk in terms of substitution in that particular application, but at the same time, it will not be the vast majority of the new copper consumption. So many things in the balance.
And the slide that we're on right now, slide 5, actually shows that some of the greatest risk is in offshore power, as you say, because cables go underground, under the water, and thus are perhaps less susceptible to sort of what we know of as aluminum's weak links. Is that fair to say?
It is fair to say, and also efficiency in many different shapes or forms is quite relevant in those applications, and safety factors as well are critical. So therefore, and you look at solar as well, which is another source of new potential copper demand. There's also within the solar power generation a lot of aluminum. Well, not a lot, but there is aluminum use as well. And both are used equally, for different parts, so to speak. So that there is already an amount of substitution already in place, with existing technology.
Gotcha. Yes, Christina?
Just jumping in on the offshore, it is interesting because both cables work as a submarine cable. And of course, the copper submarine cable has the weight is much higher than of the aluminum. And if you remember your physics class, copper works very good in shallow waters, where the offshore farms are. Aluminum works in the deep water very well. And aluminum is used more for intercontinental connection, where the cable is laid on the deeper water because of the water pressure. And this is the reason, and plus the offshore farms becoming much larger, and submarine cables need a lot of armor, a lot of insulation, and if they use aluminum, the cost of the armor and the insulation will partially offset the cost advantage of aluminum. So there is a lot of aspects as we discussed are playing a role. But for the offshore generation, I think it's important to see that the offshore is the only scalable, really scalable renewable energy generation form. And this is the risk of substitution in offshore, because we have to rely on offshore energy generation to have larger farms, and if the substitution is taking off, is taking away a larger part of the copper demand. But we see there rather going back to copper for the reasons I mentioned before.
Interesting. Richard, I want to throw over this question, first I guess going back to geography, and then maybe any thoughts on offshore while we're on this topic.
Yeah, I raised my hand to provide my
We're in a
inputs.
Zoom world now. I'm sorry.
I
I should have seen it.
I think I have a different take, perhaps. In terms of geography, I think it has a lot to do with the type of economy and the way the residential settings are. There are 3 countries that are more copper intensive than the rest of the world average. That is Japan, Germany, and China. Then you ask yourself, what makes them 3 similar? Why is that? Well, one is that there were three most industrialized. In other words, they're currently producing most of the products. So the manufacturing side is very important to that economy. Secondly, in the case of Japan and China, high rises, very dense population in residential areas, in urban areas. So in all three cases, the cost, especially the indirect economic cost of electricity failure or electrical failure or unreliable electricity is extremely high. And therefore, they tend to go for more reliable systems. So this goes down, everything goes down to money in the end. You know, it's all economics. And that's something that we all have to think about. You know, I think the loyalty to copper comes for a reason. And the reason is that, well, I think I lost.
No, we're still here. We can see
Okay.
you.
The laptop lost its connection. But in any case, I think the importance here is to make sure that whoever is making the decision, whether it's from the policy perspective or standard, you know, mandatory or voluntary, you know, these decision makers understand the overall economics of making these decisions. And I also wanted to make sure that everyone understand the competition of materials is not at the material level. It's actually at the system level. So in the case of offshore wind, for example, you know, there are many aspects that you have to consider, but in the end, it's the overall system efficiency and overall material efficiency that these designers and installers needs to consider. Sometimes they don't actually consider all the factors, and it's our job to make sure that you know is not the case. And you know, once they actually look at all the parameters and tweak with it, they can reach decisions that sometimes surprise people, including, you know, offshore wind. So, you know, there's you know reasons why offshore wind is still very pro copper compared to, say, onshore wind. When it comes to EV, I think, you know, EV as a product is a much less mature product, and there will be a lot more, you know, technological changes to that product, as a result of which material selection decisions will change. You know, for example, the battery chemistry. We talked about, you know, lithium and all of that. That is the overall material balance, but I think the chemistry of the battery will have a huge impact on material selections.
And
So if anything, you know, we need to look out for potential new chemistry being introduced into the batteries, which is a major component of the overall copper usage in EVs.
And so rather than, so Richard, I just want to interrupt right there. Thank you. So rather than dive into physics, well, let's dive into physics, as Christina was saying. So you're referring to the whole system here, and we have two perspectives on this topic. Richard, Christina challenged us to think about depth in terms of adaptation, whether it's adaptation with copper or aluminum. Clearly, as we go more offshore, we're going to go deeper. So how can that sort of interact here with the overall system that Richard was referring to? I guess either of you are welcome.
The conductor is a major contributor to the weight of the cable, but you know, it's not a bare conductor. You have insulation materials and sheathings, and you know, it's a very complex thing. So the overall flotational or the overall behavior of the cable is not just determined by the conductor itself, and the weight of it is not. It's not the major. It's not the only contributor, if you will. So there are differences between aluminum and copper cable in terms of weight and all of that, but it's not that significant in that sense. And I think, you know, the decision will be an economic decision. So if copper systems, say at higher energy density, performs better and allows less material overall being used, you know, copper system will win.
Gotcha, Christina.
We are, you know, for example, promoting higher voltage or even direct current transmissions of power, and also connecting formats so that, you know, less cables can be used. all of this requires higher amount of energy being passed through the same cable. And therefore that cable's reliability and capacity to carry current becomes more important. And in those cases, copper actually does better compared to, say, aluminum solutions. So we do have competing overall engineering solutions that favors copper, performs better, and provides a better economic outcome for the developer and the future operator of these wind farms.
Gotcha. I want to give Christina a few seconds to respond, and then we'll move on.
Can you repeat that question again?
Yeah. So we had some different perspectives. So Richard, you were challenging us to think about sort of the depth of the physical depth as offshore wind goes deeper, and so how Richard was challenging us to think about how aluminum versus copper might just be one consideration among many in the whole system. But you were talking about sort of the performance needs for depth, and so I'm wondering how you.
It's, you know, if it's the carbon buried in the ground, then of course the weight is irrelevant. So there are different factors playing a role. I'm just trying to convey the general trends, especially for cables which are not buried. And of course, I completely agree with Richard. There are different factors. For example, also the size of the offshore wind farm is an important factor. It's also important whether it's floating or it's in the shallow water. So, for example, floating, the cables, the floating cables are more aluminum because for different reasons, but also one of them is weight. So it is always about the system. And I completely agree with Richard about it. And the cost and the performance is always optimized on the system level. It's not on the material level.
Gotcha. On that point of cost, maybe Francisco, I'll throw this to you. Cost-price ratio may be a help for aluminum, but is it the greatest driver, you think, of substitution?
Well, and I think I agree with the other speakers as well that, you know, ultimately the decision will be based in cost. So obviously there is an economic decision to everything. Obviously there are some other uncertainties maybe that, you know, the copper industry maybe is not completely away from, which is the actual potential, and something that is being discussed a little bit maybe earlier today as well, is in the actual availability of material, right, of sourcing of it. So a couple thoughts on that regard. And just to throw it out there, maybe there is someone else wanted to comment. So when we talk about, I think, so obviously we don't have a crystal ball to see the future and to give you a definitive answer on how things will play out. I do think what is relevant to highlight is sort of the changes in the market as opposed to what we were discussing maybe 5 years ago, right? So I think that's important to know that most of the growth of copper consumption will come in these new applications. Therefore, you know, that is for me already a big change, okay? And obviously these new applications comes in the form of part of the solution to a greener economy, right? And when we think about the carbon footprint of the different materials, maybe something we haven't yet seen in these discussions, you know, in terms of substitution, is what is the carbon footprint of, you know, one and other material. So when you look at aluminum, which as opposed to the copper industry, is the carbon footprint of the aluminum industry is way higher. Alongside the steel industry, probably the two top in terms of, you know, priorities for decarbonization when you look at the commodities world. So correct me if I'm wrong, someone in the audience, but if I recall correctly, we had a study that around 4 tons of CO2 equivalent per ton of copper, as opposed to aluminum in terms of metal, was around 11 tons of CO2 equivalent per ton of metal. So obviously that's another perspective maybe to take into consideration. Although the aluminum industry as well is moving towards decarbonization, it's not an easy endeavor. It's very high energy intensive, switching completely to some sort of renewable power source. It's complex, maybe more complex than for copper.
So just getting back, we started the conversation talking about EVs, and increasingly we're seeing EV consumers care about the carbon footprint for the EV that they buy. Given this carbon footprint that you're talking about between copper and aluminum, do you think that could have a huge impact on which kind of car consumers might want to buy?
Yes, I think, well, yes and no. So I think that's another discussion that we've been having a lot in the last couple of years is about green premiums for metals as a whole. Ironically, aluminum, I mean not ironically in reality, but aluminum being a more carbon-intensive industry, we're starting to see more actual trades in terms of premiums for different types of aluminum. Also legislations in places like Europe with the carbon border adjustments and carbon taxes are starting to pick up for the steel and aluminum industry. Maybe not so much for the copper industry yet, but I think it's ultimately there if the end consumer will care about that or not. And we usually talk about premiums and what consumers want to do as something very sort of vague, but at the end of the day, we are the consumers. So I think the green premium things will end to, are we willing to pay more, let's say, for a phone that has green copper or not? And then to your point on EVs, not sure if maybe the consumers are still there in terms to really see where the material come from, but that doesn't mean it could change. And in some time, we're starting to see that getting more attention. I always try to use very realistic cases, so I will use my own case. I do have an electric vehicle, which doesn't...
Very on brand for you.
Yeah, exactly. It doesn't make much sense from the economic point of view because it's way more expensive and we don't have tax incentives here. But at the same time, I wasn't really aware of the specifics of what the material is coming in the car, right? So I think what I get from that is that I think it will be like a second derivative, of that analysis, but definitely somewhere where the world will tend to. So in that context, I think maybe something that we haven't discussed yet in full extent is carbon footprint, maybe as an additional aspect beyond cost or price competitiveness between the two commodities in this case.
Interesting. I'd love to, in the time we have left, and just a reminder, we will have time for questions, to talk a little bit about miniaturization, and that was part of the study here. Let me just find that slide. Could we talk a little bit about thoughts on how it could affect substitution and demand, and maybe Richard and Christina, maybe start with Christina, and then we'll throw it to Richard. We'll go from there.
Just explaining the slide for you, the orange column is the substitution loss. The blue is the substitution gain for copper. And the grayish green part of the column is the miniaturization. And the top line is the net substitution on the total copper use as a percentage. That bottom line and the top line is if you add up miniaturization as well, and then you create a percentage on the total use. Copper use. And as you can see, last year, so it's basically 2021, substitution has increased, but since stabilized. But in last year, in 2022, the miniaturization increased. So what is miniaturization? Miniaturization is a more efficient use of copper. So it's basically, it can be that the copper content of alloy is reduced. It can be also what Vanessa referred to, that the copper intensity is declining in more mature applications. And we see this happening in the last 3 years, is that OEMs and producers, as kind of manufacturers, don't substitute copper directly, that want to use it more efficiently. So they reduce the amount of copper used, but still the entire system delivers the same performance as before, or even better. And then this can happen through just reducing, developing new alloys, developing new, investing into R&D, developing new solutions, and interestingly, going back to the EVs, at the moment, some EVs use a laminated battery cable, which is combining the electrical connections, and the signal connections in one unit. So the cost saving is there, the installation cost. Basically, they can do it very easily, install in the car, and this is how they offset material cost, especially relating to copper.
Interesting. Thank you, Christina. Richard, thoughts on miniaturization while we're on the topic?
Yes, I mean miniaturization is a constant effort by the manufacturing industry. I mean, basically achieving the same functional unit with less material in there. And I think overall copper does a pretty good job in helping achieving those objectives. That's largely due to the physical quality of the metal. You know, we are I forgot the word, but essentially, you know, the metal itself, it's easier to manipulate compared to let's say competing materials. Since we're now mostly competing with aluminum in the conductive field, we do have, in my opinion, an advantage in that area overall, and it's an active area for the ICA to work in to help the downstream industries to achieve higher material efficiency for the same functions. But what's interesting, however, is that miniaturization or the reduction in overall size of functional units did not necessarily result in less material used. Instead, it satisfied the need to have higher functionality. So use EV as an example. You know, using thinner foils to make batteries did not result in less foil, less copper in weight used in the car, but instead resulted in higher battery capacity. Thinner cables did not reduce the overall usage of cables, but rather, you know, supported, you know, more functionalities, electronic functionalities inside the vehicle. So it's not an enemy from our perspective, miniaturization, but instead it's an enabler, and it makes copper more competitive, or copper-based solutions more competitive, because we can pack more functionalities in the same space and in the same weight. So again, you know, miniaturization is a natural phenomenon, and we're actively supporting that process because we don't see it as a negative to copper, but instead allows higher functionalities to be deployed.
Thank you, Richard. Francisco, thoughts on miniaturization while we're on this topic?
Yeah, well, I think, and again, I think our perspective has always been a bit more of a long trend type of view, right? So when we look at the overall amount of copper utilization, I think, and something was discussed also this morning, and again, I will take sort of a step back. I think I've been saying that for all the answers I've been giving, in the sense of we talked about traditionally or up to date, maybe the notion was that the amount of copper per, let's say, electric car would be around, could be up to 80 kilos, you know, and you know, 4 times what it is used in a traditional internal combustion engine car. We saw this morning the discussions we had around potentially that number maybe could be somewhere between 20 and 50, right? Actually, for the purpose of this study, we consider, I think, an average of 50.9.
That startled you this morning or surprise you, that frankness from the panel?
So, sorry, come again?
Did the frankness from the panel this morning, did that sort of surprise you?
Well, and that's maybe a different, and again, it's evolving technologies, evolving applications, and then ultimately, what is the main objective? And I think we all agree in this panel that the overall you know, output that you get out of the system is the main driver. So that will come in the form of different battery chemistries, maybe not really related to the amount of copper that could be or not in the vehicle. I think still things to be established. I do want to see that maybe also another trend, and again, I'm thinking now more from the miner's perspective, is that we're starting to see a bit more of a, I don't want to say vertical integration. I don't think we're anywhere close to that yet. But I do think there is now, you know, with these new applications, batteries, electric cars, there will be a bit more of a connection between the OEMs and the miners. In one end, associated to really understanding, you know, what are the benefits maybe of using one or other material, and therefore also trying to secure that material in the long term. I think that will play a role as well in how that relationship happens. I'm not sure if it will be an actual you know, fully vertical integration, as I said, but, you know, we've seen some of that. I know I'm deviating a little bit from the main topic today, but I think that's something
All related.
it's all related, exactly. And we saw OEMs, it's public information. They announced some weeks ago, Stellantis,
Yes.
Getting an investment stake in an early stage copper project, which was I think a surprise for many people. I'm not sure if something we'll continue seeing or not, but I think part of this ongoing optimization of those systems, there will be obviously a discussion of substitution of materials, but at the same time, an aspect beyond the technicalities of the actual use of the material is there a security to have it in the long term? What is the source of that material, the quality of that material? And I think that is something that potentially also can be very relevant in this overall discussion, how much penetration there will be from either one material or other.
So that speaks certainly to the long-term confidence in a lot of these supply and demand numbers. And we're starting to see a lot of OEMs go after lithium, but you're suggesting perhaps copper as well, which would certainly underscore the rising demand there as well.
Well, and to that point, I think it's obviously lithium and let's say more battery metals or metals associated to the chemistry of the batteries have been sort of the first target, because those are markets that went from, I don't want to say non-existent, but very small, to very large markets right away. So even though we are seeing a growth from, for copper consumption through these new technologies, I don't think it's in the scale that has happened for the other materials, right? And at the same time, and I want to use the parallel of those materials in terms of new applications is, batteries, we've been talking for a while now about range being such an important factor of EVs. And, the obvious solution was at some point, not long ago, that there will be a transition from LFP batteries to NMC batteries in terms of chemistries. And within the NMCs, different type of chemistries. But, we've been proven, like, I don't want to say month to month, but maybe semester to semester or in a couple of years that, the application of LFP batteries is continuing to be predominant. And, continuous improvement in that technology, and then also associated to safety issues and cost have made them potentially to continue being, maybe we were overestimating how those are going to be displaced, and that hasn't been the case. So all of those things are happening in a very short time frame. So we're only talking about here 2 years maybe of all those developments. So again, broader picture, and I wanted to restate what I was saying at the beginning. I think key aspects are copper demand or consumption, actually. Consumption growth will come from new applications. Those new applications, I think, will change from region to region, and also there is continuous changes in those technologies as we've been talking. So I think that is a different aspect to what we had in the in the last commodity super cycle, where mostly was used for construction, and most notably China, and other growing economies. So it was a bit more straightforward uses. And then I think the discussion about substitution was also a bit more straightforward. Now it's getting a bit more complex.
More complex indeed. In the time we have left, I want to throw it open for questions from the audience. So if there's anyone that would like to ask our panel, either in person or virtually, a question, please put your hand up and the organizers will come to you with a microphone. Any questions? We've got one right here.
Thank you for your insights. We spoke about physics, Richard about systems. You're comparing aluminium with copper. But copper is so much richer because of all its minor elements. We developed that metal wheel many years ago to explain to policy people that substituting copper would substitute a lot of extra elements. How do you consider that in your discussion?
Very good point.
You brought physics into this, Christine.
Extra element, which elements do you refer to exactly?
Sulfur and everything else.
So,
It's, I do share that view. Substituting copper is not as straightforward because the copper industry also supplies into the overall supply stream additional elements that are crucial to the economy. So but this is related to the the availability issue or the resource strategy issue.
Gotcha.
So in that sense, copper is actually has a additional flavors that makes it more attractive, in my opinion.
I completely agree with Richard. So this is basically, it's on the supply side, and we are more looking at the demand side, how to use the virgin or recycled copper and the alloys. So looking at the impact on the demand. So whether substitution is reducing demand, which will have an impact on the supply-demand gap. And according to I mean, CESCO will also confirm it, the impact will be there, but it will be not significant to breach this gap.
Gotcha. Other questions from the audience? Well, if not, in the time we have remaining, I want to ask each of our panelists sort of a closing question. And it occurred to me as I was getting off the plane here in Santiago on Sunday that not only has Santiago changed a lot since the conference was last in person in 2019, but certainly the broader economy was. Christina and I were on the same panel in 2019, and we did not have as much of a discussion on EVs as we did perhaps then, or other green energy transitions, and it was still very much sort of shady, sort of cloudy, I guess, when we were looking forward. And so if I could ask each of the panelists to talk, if we were to come back here in 4 years, and let's hopefully it's not 4 years until we're back again in person, but where do you think we will see the biggest use of copper? Do you think it'll be fully electric? Do you see something else coming on the horizon? Any black swans we should be looking out for? Where do you think demand will be? I guess we'll just start with you, Christina.
Francisco is the long term, but I think I just jump in, okay? I think that situation will be very similar. That the question is here the economical question and an energy price question. And then as the energy price increases, energy efficiency will be more important. Basically saving electrical loss. And this will be in favor of copper. So in my view, we will see this. In my view, the energy price crisis will continue. And it will be on the level of the applications. Definitely energy efficiency will be more important. In terms of miniaturization will continue because this is a natural progression of developing applications and making them better, more efficient. In terms of substitution, I think there are some applications which are the substitution already finished. But again, if the new R&D wave is coming up, using alternative materials, it might kick off a new substitution wave. But again, it will be slow because at the moment we don't see a strong impetus, neither from the material cost side nor from the technology side to significantly increase substitution.
Gotcha. Richard, to you, and then last word to Francisco.
In my opinion, I think 4 years from now, the electrical side of new energy vehicles or electrical vehicles will pretty much stabilize. You see the continuation of renewables being a major factor in future copper applications. But in terms of vehicle, I think moving into smart vehicles and the infrastructure related to smart vehicles and overall smart cities and smart manufacturing will provide a new set of drivers for copper. Functionality, I mean, basically that whole concept will bring the demand of a new set of infrastructures for which requires conductors, and copper will definitely benefit from that.
Thank you. And Francisco, over to you.
Yeah, so I think my last comment will be on the miners side, and I think, again, was discussed and touched upon, I think, this morning. I think in 4 years' time, I think the mining industry should have sort of a clearer picture of what is the pathway towards bringing new copper units to the market. If it's not solved in 4 years, then I think something more critical could happen in terms of not only substitution, but maybe demand destruction. That's maybe another sort of definition could be out there. So I think it is great opportunities that we've been all discussing, even though there are some risks on the substitution itself, which we discussed. This overall, or maybe me being Chilean, I'm very bullish on copper, but I think it's up to now on the supply side to really being able to bring that on the table. And I think there will be, as I mentioned before, maybe something changing in terms of that, again, not per se vertical integration, but some sort of integration between end users, not end users, but end producers, so to speak, and the mining industry. So maybe that's sort of a different shift that we'll see in 4 years' time.
Gotcha. Great. Thank you. I think it is almost 4 a.m. in Beijing, so we will let Richard get back to sleep. And ladies and gentlemen, if you please join me in thanking our top-notch panel, and thank you for being with us here today.
Thank you, Justin.
Thank you very much,